Hello guys, my name is Nibun Vats and today I will teach you guys that how to compare two functions to find the time complexity. Well, what do you mean by time complexity? Well, if you ask the definition from a normal person, then he or she will say that when we can say that one function is greater than the other function, then we are actually comparing two functions. Well, if you ask the definition from the computer science student, then he or she will say that when we can compare two functions asymptotically, then we are actually comparing them. Well, to understand this, let's take an example in which fn is equals to n and gn is equals to n square. Then we know that n value is smaller than n square. That's why we can state that fn is equals to small o of gn. Now, before we do questions, I would like to mention some rules, some properties that you can remember so that they will help you to solve the questions. Okay, so if you look at the first property, then it is saying that 2 to the power of n is smaller than n to the power of n. Well, if to prove this, let's put n equals to 4, then you will get 2 to the power of n equals to 16 and 4 to the power of n to the power of n, which will be 256. Well, 256 is obviously greater than 16, that's why this rule came. Now, second rule is saying that n factorial is smaller than n to the power of n. Well, we know that n factorial is nothing but n into n minus 1 into n minus 2 into n minus 3 and so on. Whereas n to the power of n is nothing but n into n into n and so on. And that's why this rule came, because n to the power of n is obviously greater than n factorial because of this. So if we combine these two rules, then this rule came that 2 to the power of n is smaller than n factorial, and which is smaller than n to the power of n. Now the fourth rule says that n is greater than log n. Well, if you put the value of n equals to 2, then log n 2 will be 0.3. So obviously 0.3 is smaller than 2. So that's why this rule came. Now the fifth rule says that n is smaller than log n to the power of n. Well, I will explain this rule when we will do questions. Okay. So now the sixth rule says that log base 2n is greater than log base 3n. Well, log base 2n is what? Well, log base 2n is nothing but log n divided by log 2. And log base 3n is what? Well, log base 3n is nothing but log n divided by log 3. Now we know that log 3 is greater than log n. So that's why this rule came, because it is present in the division. So that's why this rule came, that log n base 2 is greater than log n base 3. Now if we look at the graphical representation of these these functions, then we can see that n factorial is the greatest function, then 2 to the power of n, then n square, then n log n, then n, and then log n, and the last one is 1, which is nothing but the constant one. So we can see that n factorial is the greatest function, and we can say the constant function is the smallest function. So if we look at the examples now, then we can see that it is asking that which one of the following is false. Now if you look at the first option, then it is saying that 100 n log n is big O of n log n divided by 100. Now if we remove the sign of big O, then what we will get? Then we will get 100 n log n is less than or equals to n log n divided by 100. Now we know that 100 is nothing but the constant, and in asymptotic condition the constant doesn't matter. I told you guys this many times. So that's why we can remove it. Now n log n is obviously equals to n log n. Obviously it's true that n log n is obviously equals to n log n, and constant doesn't matter, I told you guys. So that's why this is true, that n log n, or we can say 100 n log n, is less than or equals to, this sign is present in case of big O. So 100 n log n is less than or equals to n log n divided by 100. So that's why this condition is true. Now, but in the question it is asking that which one of is false. So that's why this is not our answer. Now if we look at the B option, sorry, Now if you get the B option, then it is saying that root log n is equals to big O of log n. Now we know that root log n can be written as half log n. Now we know that half log n is equals to log n. So we can state that half log n is equals to big O of log n. Why? Because if you remove the sign of big O, then we will get less than or equals to. So equals to sign is present here. So that's why we can say half log n is equals to big O of log n. But obviously the value of log is greater than log n. Right? Because you can prove it by yourself that by putting n equals to 2, then you can compare the two functions and you will find that log n value will be greater than log n for any value of n. So in the question, but it is saying that log n value will be smaller than this one. Log n value will be smaller than or equals to log n. So that's why this condition is true. This condition is false, because in actual the value of log n is greater than log n. So that's why this condition is false, and this is our answer. But let's see the other example. Let's see the other options too, so that we can better understand this. So in the next example, it is saying that n to the power of x is equals to big O of n to the power of log y. Well, in here I will like to correct you guys that this is not log y, this is just y. So it is n to the power of x is equals to big O of n to the power of y, and value of x is smaller than y. So if we put x equals to 2 and y equals to 3, then it will become n square is big O of n cube, which is obviously true, because if you remove the sign of big O, then you will get n square is smaller than or equals to n cube. So this condition is true. Now if we look at the D option, then it is saying that 2 to the power of n is not equals to n. Well, we know that 2 to the power of n is nothing but the exponential term, and n is normal linear function, is normal function. So that's we know that the growth rate of the 2 to the power of n, or the exponential function, is always greater than the normal functions, the normal linear function. So that's why this D option is true, because this is also saying that 2 to the power of n is not smaller than n. Okay, so that's why this option is true. Now if we look at the next question, then it is saying that fn is equals to n square log n and gn is equals to n log n to the power of 10. So to do this question, let's take the common part out, and the remaining part will be fn is equals to n and gn is equals to log n to the power of 9. Why? Because the common part is nothing but the n log n. So we will take it out, and when we will take it out, then fn will remain only n and gn will remain only n will be common out, and so that's why, and then log will be common out, so only log 9 will remain. So that's why this came. And we know that from the fourth rule, if you remember, that value of n will be greater than log n. So that's why in this we can state that gn is less than or equals to fn. Why? Because of the fourth rule. So that's why we can say that gn is equals to big O of fn. And let's then we will see that whether this option is given in the given option or not. So we can see that the B option is saying that gn is equals to big O of fn. So this is our answer. Now if we look at the next option, then we can see that it is saying that let fn and an will be the worst case and the average case respectively. Now we know that the value of the value of the worst case is always whether greater than or equals to the value of average case. So that's why we can say that average case is less than or equals to worst case, or we can say that average case is equals to big O of worst case. So we will see that whether this answer is given in the given option or not. So we can see that A option is given, is saying that an is equals to big O of wn. So this is our answer. Now if we look at the next question, then it is saying that G1 and G2 are the two functions and the growth rate of these functions are given. Well, to solve this type of question, we always bother about the functions whose when the value, we always bother about the values when the n value will be when n value will be infinite. We always bother about that value only. Okay, so we will check that what will be the value what will be the value of these functions when n is equals to infinite. We will see only those values, and on the basis of that value we will conclude the answer. So we will see the growth rate now. So for 0 to 99, the Gn will be n cube and G2 will be n because of this condition. Now for the value of 100 to 9999, G1 will be n cube and G2 will be n cube now. Why? Because we can see that after 100, the value of G2 will be n cube. Now for the value of 10,000 to infinite, the value of Gn will be n square, because it is saying that for the value of n, for the value of greater than or equals to 10,000, the value of Gn will be n square. So that's where this came, this one. And the value of G2 will be n cube. So we can see that for n equals to infinite, the value of Gn will be n square and the value of G2 will be n cube. So the value of G2 is greater than G1. So we can conclude that G2 is greater than G1. So that's why we can say that G1 is bigger of G2, or we can say that G1 is smaller than or equals to G2. So we can see that B option is saying yes, B option is saying that this option, this is our answer. So now, for this video, this is enough. From the next video I will start divide and conquer course, and in that course we will do recursive type of question, and this comparing two functions will help you to solve recursive type of questions. Okay, so thank you guys for watching. Have a nice day.